Okay, so let's look at the first one. I could not factor it, so nothing could cancel. There's no hole. What causes 0 down here? X equals a -4, so that's going to be a vertical line. And then x squared divided by x is linear. So I did long division, or you could do synthetic. Since you're dividing by a pretty thing, you just have to use -4 because you use the 0, not the factor. And I got x minus 6, okay? And if I look at Desmos on that one, I can check my answer. Okay, so right now, here's the vertical, here's my slant, the red is my graph right here. So I can see that, oh, yeah, looks like I'm right. Okay, let's look at the next one. Again, I tried to factor, I can't. So if you can't cancel, there can't be a hole. All right, and then, sorry about that. See if I can get this to, there's a little brightness there. It might be the window, but we'll try. Maybe that's better. All right, so if you can't cancel, there can't be a hole. Vertical is whatever causes 0 here. Leading coefficients, those cancel. I get 2, so y equals 2. All right, so I am going to go ahead and let me see. Let me go back to Desmos right here. All right, I'm going to unselect those, and then let's see. We have this one, and where are we at? There we go. All right, maybe slide over. All right, so you can see your vertical asymptote in the black, horizontal in the red, and then the blue, those are your the function that you're graphing, okay, your rational function. All right, so you can check your answers on these. All right, oh boy. All right, I'm gonna pause for a second. All right, okay, here's the next one. So again, doesn't factor, so there can't be any holes because nothing cancels. Now, if you look, x squared can never cause 0 because negative squared is positive, 0 squared would be +3. There's no way to get a negative down here, so none. If you look at the leading coefficients, that's 1 over x. As x gets really big, that goes to 0, okay? And so I can graph that one. Where's my Desmos here? And this one's kind of a weird one. Where are we at here? Because, again, remember, vertical lines are brick walls, but horizontal lines are suggestions. So you can see it actually crosses at 0, 0. That is okay. It is an asymptote as the ends go off to infinity. All right. So again, remember, you can cross a horizontal. Those are suggestions or maybe just for part of the graph. All right. The next one, you might be like, Julie, I have no idea what you want. All right. So I factored, okay, and I have something that cancels. So remember, you get a new function. So this original function, if you cancel out, it's going to look like the new function, which is either x plus 1 over 2, or really that's linear, half x and plus half. So you're going to have a hole, and your hole is going to be at whatever causes 0 here, which is 1. And then remember, you sub 1 into the new function to get the output. So 1 plus 1, 2 divided by 2. And if I graph this one, all right, so let me go to Desmos. All right, let me get rid of, I don't need this one. And let's see where we're at in that. Okay, so if I graph, here's my original function. Nope, I just deleted it, didn't I? Nope, that's my original. And if I go to 1, 1, can I get there? There you go. It's undefined because 1 would be dividing by 0, okay? So this original function, though, is going to look identical to this, okay? So if I hide this one, okay, and I can pull that over a little bit. So here's that both of them are on. Now there's the original. Now I'm doing the new function, hiding the original. The only difference between these two graphs is the new one is okay at 1, 1, right? Like I could plot 1, 1. That's fine. So they're going to look the same. It's just that that one is going to have a hole. All right. And so where am I at? I need to get back to where I was. All right. So they're going to look the same. The new function, which is really linear, is going to look exactly like this guy. It's just going to have a hole there. All right. The next one. All right. So again, tried to factor, couldn't do it. You could do long division or synthetic because this is pretty. Vertical is whatever causes 0. Notice that when you reduce, it's linear, it's an x. So you have to do either long division or synthetic in this case, because again, you have a pretty one. Use the 0, -4. I did synthetic, synthetic, and I get x minus 2. So that's going to be my slant. Y-intercept is when you have a number in the y spot. So I sub 0 in for my x, and I got 3/4. So 0, 3/4 is my y. X-intercepts are when you have a number in the X spot with 0. So I set it equal to 0, the whole function. I want my output to be 0. Multiply both sides by x plus 4, which means basically the numerator has to equal 0. Didn't factor, so I tried quadratic formula, and I started getting imaginary numbers here. So there is none. All right, so let me graph this one, and let me get back to Desmos. Okay, sorry about that. Before I go to Desmos, I'm going to try to sketch this without my calculator, and then we'll go back to Desmos. So I have my asymptote, I have my slant. So I started at a -2 in rows and ran. So rise and run, rise and run, rise and run. And then I have my vertical. And so what I did is I subbed some stuff over here. I knew there were no x-intercepts, so that was nice. Now I'm kind of in the process of subbing over here. So at -5, I subbed in, I got 25, -10, so that's what, 15. I got a -18. So over here, you know, I'm kind of way down at a -18. But that tells me enough that, you know what I mean, I think it's going to kind of be in that type of space. And then this one, I subbed in enough points to feel like I'm in that space. I'm kind of going into that guy a little bit. All right, so let me go into Desmos, and I have that typed in so I can double check. Okay, so you can kind of see where I'm at. All right, let's see what I subbed in. I subbed in -5. So where was my -5? I could plot it, but it was around there. I just saw it flicker a second ago. But anyway, that's over there. I graphed my asymptotes. Okay, so here they are. So you can kind of see how they're, you know, holding that thing in, right? So I have my vertical asymptote, which again is a brick wall. And then I have my slant right here. And again, my graph's not perfect, but it's good enough, right? Because I'm accurate as far as there's no x-intercepts. This guy is above. Okay, that's a fraction above. So there's no x-intercept. There is a vertical. There is a slant. This guy's kind of trapped in here. This guy's kind of down here. All right, I'm going to pause and let's just do this. Okay, I went ahead and graph this just to save some time. Now, when is the left side of the function greater? So the left is the red. So the red function is greater here from, let's see, I'm going to pull in from that one and pull in from this one, and then we can get that. So it looks from like a -1.667 that the red one is higher, the output's higher. But then notice at 0, the output gets lower. Now, way up here, if you keep scrolling, you're like, oh my gosh, it looks like, you know, that thing's going to cross, right? Okay, so let's kind of zoom in there. All right, I'm going to do the blue, and then I'm going to pull from the red and see where they cross. And it looks like at 3, okay? So if I go back here, I can be like, okay, these are the x values, okay? Because remember, y values we only use pretty much on range. So these x values are when the left function, this guy's bigger than that, union to here. Now, if you want, it might be easier to bring these over and do 3x cubed minus 4x squared minus 15x, and then compare it to 0, because that's your, then you can just have one function compared to the x-intercept, although I might draw it as 2. Okay, so give me a second. I'm going to pause just to show you that because it might be easier to look at. All right, so this is why a lot of times with these inequalities, people like to set it equals 0, because then you're like, oh, okay, so it crosses there, right? And then it crosses here, and then it crosses again here. So then I'm asking you, okay, when is this function, what, greater than or equal to 0? So I'm just going to take a snip here if it lets me. Where is my snipping tool going? It doesn't want me to, oh, there it is. Okay, sorry, a little bit of a delay. So if I just use my snipping tool, maybe, if it lets me, there we go. All right, and then I'm going to take a highlighter here. Then you can see that this function is positive there, inclusive, so solid dots, and it's positive there. And notice that's what we got from the other graph. I just think it's easier to see here, but that's up to me, or up to you. The other thing is you could do test points where, you know, you look for x-intercepts and do test points, but if you can use Desmos, I would use it. All right, I'm going to pause and continue with more problems. Okay, on partial fraction decomposition, I look at my base. My base is x minus 1, so I wrote it by itself, and it's squared, so then I had to write it again squared. My base, just this part, the inner part, is linear. A step down is a constant. So I did a here, and again, you look at the base. The base is linear, step down is a constant. To cancel, I did x minus 1 squared there, x minus 1 quantity squared there, and the same here. Okay, and when I do that, all of that cancels, which is your goal. One of these cancels, and both of those cancels. So you get 6x minus 11 equals a times that, and then plus b. 1 is a pretty number, so I subbed in 1. 6 times 1 is 6 minus 11, negative 5. That gives you 0. B is a negative 5, and you're done. Now, I don't have another pretty number, so I pick 0 next. 0, I get a negative 11. This 0 is a negative 1 times a. These are glued together, have nothing to do with this over here. And then here, don't forget your b is a negative 5. You cannot add, cats and dogs. These are separate. So negative 5, you can bring it over as a positive 5 and get a negative 6 equals a negative a, and then a is 6, okay? And so then I know my a is 6, so I put it above my original, and I know my b is what, negative 5, and put it up here. Now you can either put plus a negative 5 or minus a normal 5. That's up to you. Now, the only way you can really check your answer is to graph the original and to graph the new one and to see if they look the same. Okay, so I did that. So I'm going to go to Desmos because this is about it. All right, so I graphed my original function. I called it O of x. There's my original function. And then notice I graphed my partial fraction decomposition, and they are the same graph. So I know that I decomposed it correctly. All right, I'm going to pause again, and I'll do the next one. All right, here's the next one. And again, if these aren't factored, you need to factor them, all right? Because you have to be able to see what's going on. So this one, I did the x minus 1 by itself, because that's a single factor, and then its linear step down as a constant. The other factor is x squared plus 1, and it is a quadratic, so a step down is linear. So that's why I used a for my first constant, bx plus c. Okay. Then you multiply by all your factors to cancel them. So I did x minus 1, x squared plus 1 are all 3. All of this should cancel. Part of this canceled, and part of this guy canceled. And make sure if you have a quadratic thing, you need parentheses because of the distributive property. All right, and again, I might do these differently than my math lab or Newton or any of those products because I think this is easier. What I do is I sub in anything that causes 0. So x equals 1 causes 0. So I just subbed it in here. I get 5 minus 6 plus 7. Here I get what? 1 squared is 1 plus 1. I get 2a. But this is going to all be 0. So all of this is going to equal 0. That's all going to go away. All right, and so I get 2a equals, what is that? 6 divide, I get 3. Okay, now that's my only pretty one, but I can still pick easy numbers. So I chose 0, 0, 0, 7. So I'm going to get 7 over here. Up here, let's see, what do I get? 0, that's going to be 1a. Okay, so, and a is 3. So 1 times 3 is 3. For this part, I get, this goes away. I get 0 plus c. So 0 plus c, and then I get 0 minus 1. All right. So this part is going to, that's going to go away. I'm going to get a negative 1 times c. And again, this is cats and dogs here. These are c's, these are not c's. They can't add together. Bring the 3 over, I get 4 as a negative c. Either divide or multiply, but c is a negative 4. And then I decided to do 2. I usually avoid negatives. I didn't do a negative 1. So same thing, I sub 2 in here. So 5 times 2 squared minus 6 times 2 plus 7. And then I sub the 2 over here. 4 plus 1 is 5. And again, I did all the algebra. You might want to pause and look at it. But basically, I just solved x equals 2. You might have to do the distributive properties, so be careful. All right. And I just did all the math, and I got b equals 2. Okay, this is a 2. Now, so then I sub in, there's my a, there's my b, there's my c, all over how I kind of decomposed it. Now I'm going to graph it to check my answer. All right, so let me go on to Desmos quick to see if I'm right. All right, here I graph both functions. I'll hide the original, and I will hide my partial fraction. And you can see they're right on top of each other. So I feel good. I know that I did this part right. Okay, this is the end of part 1. Again, you might have to slow it down, rewatch it. If you need some other videos for me to clarify, let me know and I will gladly help you out.